Alright guys, good morning. So hopefully you guys have all seen my email by now about things going on campus, so I figured it would be best if we just did a remote review. So I will post this video on Blackboard as well as having it on sent to you via email. So this is going to be an exam 3 review. I also have notes posted on Blackboard that I will be following. I'm not sure if they're posted on Blackboard yet, but they certainly will be read by the time this video is sent out to you guys. I'll also be using an exam 3 review worksheet to get some questions and do some examples. All right, so before I get started, some announcements. So first and foremost, we have exam 3 is going to be on Thursday of this week. That is 11-21. So it'll be Thursday at the normal time at 8 a.m. Next, my office hours for this week. I have bonus office hours on Wednesday from 10 a.m. to noon. And I also technically have office hours on Thursday from 11 to 12, like normal. But this will be after our exam, so I imagine that very few of you guys will actually come to this set of office hours. The only things that we have due, we have our last assignment due this week. Our last assignment is going to be 9.3, and again, this is due Thursday at 2 p.m. as per usual. Please, as always, do this before your exam. Section 9.3 will be on the exam. So again, that's due at 2 p.m. Sorry, still trying to figure out my margins here with the way that the camera is set up. Yeah, so exam 3 will include 9.3. Please do your homework on that beforehand. All right, so that's enough for announcements, and let's see. I've got about this far over on the page before you can't see anything anymore. All right. So let's get started with some review. So in section 6.1, we were doing absolute maxes and mins. Okay, so we had a process for finding absolute maxes and mins. It was kind of similar to the process that we used for finding relative maxes and mins. Abs here, again, means absolute. Okay, so our process for finding the absolute maximum and minimum of a function f on the interval a comma b can be found as follows. So first, we're going to find the critical values of f. And again, this is two cases. This is where f prime equals 0 or where f prime does not exist. This is exactly the same as it's always been from section 5.3 onward. Next, we're going to make a chart. So our chart's going to look something like this. It's just going to be a T-chart where we have A and B. These guys are our endpoints. And then we're going to put any critical points. Let's see if I can grab another color here. This guy right here there's going to be any critical points. Okay. Now step 3, we're going to plug the left column into the original function. Again, here we're plugging back into the original function, f of x. Okay, and this is going to give us our right-hand column. So the right-hand column will be filled with values of f of x. Okay. Now step 4, we're able to draw conclusions. The biggest value on the right is the absolute max. And it occurs at the corresponding value on the left. Likewise, the smallest value on the right is the absolute min, and you can guess that it occurs at the corresponding value on the left. So let's do an example of this, of how it looks. Let me make sure that I have nothing more to say here. Yeah, so then here we'll see in a moment via example the sentence that we're going to write at the end of these kind of problems. Okay. So doing an example of this, again, let me recenter my papers and check my margins. So an example of this is as follows. This is going to be number 3 on the review worksheet. So we have our function g of t equals 2t cubed plus 3t squared minus 12t plus 4 on the interval -4 to 2. Okay. Here we're going to take our derivative, g prime of t equals 6t squared plus 6t minus 12. I'm going to set this guy equal to 0 and solve. So I'm looking at 6t squared plus t minus 2, which again I can simplify into 6 times t plus 2 times t minus 1. So I see that I have 2 critical points, or critical values rather, at t equals -2 and +1. Okay, now I'm going to make that chart over here. So I start with my endpoints, -4 and 2. And the reason why I start with my endpoints again is because I want to know which critical values I need to include. So for example, if my left endpoint was 0, like in the case of problem 2 on the exam review, I wouldn't include this -2. I wouldn't need to test it. But since I start at -4, I'm going to go -4, -2, 1, and 2. Now again, these are my, I guess we'll call them t values, and I'm going to plug them into my original function g of t. So g of t here is equal to 2, so I guess let's just do g of -4 is equal to 2 times -4 cubed plus 3 times -4 squared minus 12 times -4 plus 4, which if I open my solutions to this, see how written out they are. Yeah, so this guy, if I plug it in, I get -28. G of -2 equals +24. G of 1 equals -3. And g of 2 equals 8. And again, I'm just plugging these all into my original function up here. Okay. So, that being said, I have a 24 here, a -3 here, and an 8 down here. Okay? So, let's get our sentence going. We know that the biggest value is going to be, this guy is our max, and then this guy up above is our min. But we want a sentence. Okay, you need to write a sentence. If you do not write a sentence, you will lose points. Okay, we know that the absolute max is 24 at x equals -2. The absolute min is -28 at x equals -4. Now again, we talked about how the absolute maximum and the absolute minimum, those values are actually like the peak or the valley, right? So we had the example of Kylie Jenner, like we do care that she made it to a billionaire, but we also want to know when or where that happens at. So I guess here I should technically have t's. So again, Kylie Jenner became a billionaire at 18. So her absolute max is 1 billion at t equals 18, or however long it is. Maybe it was 20, I don't know. This is the general process. We did have a few fringe cases here where we had no absolute max or min. In order for this to happen, there would have to be an asymptote, or if I didn't give you an interval. Okay, in either of these cases, to figure out whether it goes to infinity or not, you need limits. Again, this case up here is really the case that I care about. I want to see that you're able to make the chart. As you can probably guess by the review worksheet and the nature of the questions I asked there, this kind of fringe case down here is not of huge concern to me right now. But I'm happy to go over examples with you guys if you have questions. All right, moving on to section 6.2. So section 6.2, we have optimization. Okay, so 6.2, we have optimization problems. And again, chapter 6 was the one where we learned a skill, and then we use that skill in word problems. So this is really just doing word problems.